Hello, dear friend. Today, let's discuss the binding energy of different chemical states for the oxygen peak. First, it should be noted that most transition metal oxides have their oxygen peak around 530, and the peak width narrow compared to other components. This includes titanium oxide, you can see the lattice oxide, vanadium oxide, copper oxide, zinc, chromium, manganese, iron, nickel, and cobalt. The lattice oxide are all around 530. For many of the pure oxide samples, there is a second higher binding energy peak that can be ascribed to contributions from a defective oxide or hydroxide, or from carbonates, as their binding energy are quite similar between 531 and 532. Their peaks often overlap with each other. Let's go back to Advantage software. The reference for the oxygen binding energy here is a mix-up. For the organic carbon-oxygen single bond and the carbon-oxygen double bond, actually the single bond, the binding energy should be 533. For the double bond, it's between 531 and 532. Let's clarify this. So for organic analysis, inspection of carbon spectra should be necessary. For aluminum and silicates, the oxygen binding energy is also between 531 and 532, while for silicon dioxide, the peak binding energy is around 533. For organic silicon, the oxygen peak is around 532. So you can see the interpretation of oxygen spectra is not always straightforward, apart from metal oxide. The binding energy of other compounds and species fall within a same very narrow energy range. So oxygen peak tend to be broad with multiple overlapping components. It's complicated for peak fitting. So when we do peak analysis for oxygen, so it's recommended we do perform peak fitting of other elements first, and then analyze oxygen spectra at last. Thank you for today.